Yay.
Yeah, okay, no, it's good. So great, how are you doing?
Good, I'm good, thank you. Yeah.
That's nice.
And you?
Okay, me too. Thanks for asking. So maybe tell us something about yourself, just a couple of words, and we may start.
Okay. I'm well. I will go through this in the beginning of the talk, but I'm French actually. Came to work in Norway 15 years ago. Initially for Opera Software, the web browser company, and 3-4 years ago I joined Microsoft to work on try new challenges and new opportunities. I think it's really good company to work for. I was amazingly surprised.
So thank you. I wish you luck, and you may start.
Yeah. Okay, let's try to share my screen.
Yeah, exactly.
Can you see the slide?
Yes, it works. Everything is fine. So you may start.
Let's try to go full screen. So you just see the slides. Perfect. All right. Well, thanks, Olga, for a nice introduction and for having me today. Just in case, for the people who may watch the talk later, my name is Mathieu Henri, and you can find me online as Visio1. My computer background is split in three aspects. When I was 6-7 years old, I joined the local code club at my hometown, and I really liked how the teachers introduced a new concept or a new primitive, like how to draw text or line every week, and they asked us to be creative with that, to create something. And just writing a few lines of code and seeing some pixels on the screen was really magical for me when I was just a few years old. And that really got me hooked to computers and programming. I try to bring back this magic in the code club that I created 2 years ago at the school of my daughter, and like introducing kids to programming via creative coding. As an extension of creative coding on the code club that I joined as a child, I got into the demo scene about 30 years ago. And the demo scene is a movement that pushes the technical and artistic limits of pretty much any platform. It's very much creative coding, but that goes even beyond, like really tries to dig into technical aspects as well. So it's really, really fun way to learn. And nowadays, I am software engineer at Microsoft, where I build software for millions of people. My team works on what we call the Midgard applications. They are high-value components, all related to people experience, such as profile card, that shows some information about a person when you see a name or photo, the contact editor, photo picker, profile picker when you add to mention someone, and some components in Microsoft Search. All these Midgard applications are used in 6 platforms on the web, from IE11 to Android, iOS, Mac, Win32, and Universal Windows platform. They are used in over 40, close to 50 Microsoft 365 applications, such as Outlook, Word, Excel, PowerPoint, OneDrive, SharePoint, Office.com, Teams, and so on and so forth. We work on a big mono repository with about 300 packages. We are around 200 active contributors at the moment. And we have in the orders of hundreds to 200 million users. So you can see some of the components on the right-hand side, and they are also used on the Microsoft Bing. If you connect your account to your company, and you can search for company-wide documents and people. And this is a big mono repository where everything that can be reused is reused, and we use TypeScript.
Matthew, I'm
Yes.
really sorry to interrupt you, but we're seeing your script, kind of. So can you a bit shut it down? Because we didn't. Yeah, now it's okay. Now it's okay.
How that is. Right.
Because we haven't seen your presentation.
No?
Yeah, and now it's okay. Now it's okay.
But yeah, share.
Yeah, it's okay. So you may continue.
And if I do this?
If it's like this, so we see a black box.
Okay, that's a bit annoying. All right, let's continue like this.
Yeah, okay, thank you.
But didn't work that way in the test yesterday. Anyways, so Midgard is really a big set of applications used across many pages and many applications of Microsoft 365. And we use TypeScript for most of the code. And about 70% of the code is reused across all platforms. So that gives us a really, really big surface and many challenges and opportunities to break things. Right. So it's clear to all of us today that we live in extraordinary times. With the pandemic going on, we see more people using online tools to work from home. And it's especially important to test and maintain our software. So today, I would like to talk about end-to-end testing, a world of web, mobile, and desktop applications. I would like to explain some of the things we learned, how we improved some of the techniques, and some of the challenges and things we have ahead of us. So the plan for today is to talk about software testing in general, then component testing, which we have seen a bit with Charlie and George before. Then we'll go to end-to-end testing and visual regression testing. So starting with software testing, if you write and ship any piece of software, you have to write some form of test to ensure that the code you write is conform and meets the quality requirements. Really, that's what it's supposed to do. So looking into software testing, you will encounter the test pyramid, which is really the foundation of testing. The basic idea is that the amount of test is the inverse of the abstraction level. So at the base, you have unit tests, which are really isolated and really fast to run. Then you go into service tests, which are also called integration tests, that test the interface between different services and APIs, which need a bit more integration and are a bit slower to run. And finally, you have UI tests, which require a lot more integration and are obviously slower to run. For Midgard, we do not do service tests or integration tests so much because the developers of these services or that we integrate with, they really test on their side. And we write a lot more end-to-end test or UI test, which also covers all the layers of abstraction. So that's how we go. Another notion which is really important is the code coverage, which is related to the amount of code that your test covers. So some teams try to aim for 90 or 100 code coverage, but that is not always possible. If you write TypeScript, because of the strong typing, you might have to write some never clauses, which are by definition never reachable. And then you cannot get 90 or 100% code coverage. So you need to write different types of tests to get full 100% coverage. And it gets really tricky to get your full code coverage or a good picture of code coverage when you combine different types of tests. So for Midgard, we do not chase a really high percentage of code coverage. We just try to cover more than the happy paths to make sure that we test bad scenarios. But also we use the code coverage more to guide the type of test that we write, that we should write, where we have some gaps. And so that's really a guideline how you should use code coverage. Overall, our testing strategy for Midgard goes this way. We have a foundation of static test, which is using TypeScript and strong typing. We use ESLint and Prettier to make sure that the code is statically correct and that we have strong typing everywhere. And that gives us like a very strong foundation as we write the code. Then we have unit tests as usual. And then we move on to more visual things like visual regression tests like component test and end-to-end tests that really test full scenarios. Eventually, because the Midgard applications are used in many applications, and with deep integration into, say, Outlook, to use the Outlook functionality to send a mail or to start conversation with someone, and if you're in Office to share documents or these kind of things, we need to do some manual tests to validate a build. At this point, we roll out the code to the outside world, and we do that gradually, and we monitor and have real-time alerts on any of our telemetry, which gives us performance alerts or reliability alerts in real time, and we can act on that and roll back very quick if there's any problem. So we move on to a second aspect, which is component testing, which we have seen a bit with Charlie and George, previous speakers today. And this is about validating your components. The Midgard applications are built using TypeScript and React. And so we build UI components and we combine them together and with a lot of logic and data fetching. So we need to test these components. You heard about Storybook in the previous talk, and we use it to validate the components. It's really the perfect tool to test your components in isolation, and it's UI framework agnostic. It works with anything. And the good thing also with Storybook is that there are a bunch of add-ons where you can run, for instance, accessibility tests, which are extremely useful. Using the component stories format from Storybook, the tests look a bit like this. Here are two stories where you export a test called button and two functional components that show static props. A text button which just says hello, and an emoji button that has a bunch of emojis. The nice thing about the component stories format is that it's really simple and very versatile. You can use it in different ways. Here is an example of component tests from Midgard, where we test the organization panel. And in this case, I highlighted the code for the ghost organization entry, which just renders static setup props. There are some limitations. The Midgard applications, they do not live in isolation. They really are embedded in many applications across multiple platforms. And also there is quite some overhead to Storybook itself. And Storybook works very well for web. It works okay for native, but it's not there for Windows and Mac. So we're working on something. How we test the Midgard components is that we use Storybook for the dev loop and CI. And we are working on leveraging the component stories format to write a simple component test that would very quickly render the components, and then we can add all these extra features like accessibility test and performance testing, which you can do with Storybook. Just that in a more lightweight version. And this simple render would be extremely easy to develop across platforms. That's another big advantage, which is not possible with Storybook at the moment. Then we move on to end-to-end test, which is about testing complete user scenarios from end to end, like really from the full spectrum of your application lifecycle. So we do that to test many user scenarios, but also with visual and performance regression testing in mind. So first, you need a way to automate your task, and there are different ways on different platforms. What we chose for Midgard is, after testing different toolings, was to use Appium on Mac. Appium works on more platforms, but that was really the best fit there. On Android, we use Espresso, which is specific to Android, and it's really fast and reliable. And the same can be said for XE UI tests for iOS. On Windows and Universal Web Platform, we use WinAppDriver, which is really the best fit for all Windows platforms. And on the web, we use Playwright, which is a a node library written in TypeScript to test in Chromium, WebKit, and Firefox, and it works in all platforms, Windows, Mac, and Linux, and on CI. It's really, really good fit. Some other tools that we looked at were Selenium and Browser Stack, which have been there forever. They work with all browsers, but the setup and the developer experience is really not great. Another one we also looked at is Cypress, where the developer experience for web testing is amazing, but we need to cover more browsers than what they support at the moment. So now that we have a way to automate our test, we need to run them, and there are different ways to do it. You can import the test code, like any library or any import in your code, or you can inject it using the task runner. And you can do that using a live application or a test application. And again, you can also do that with live data or mock data. For native, they typically target a single piece of code, target a single application and single platform. So things are really more isolated, and that allows them to really test in a test application, import the test, and also use mock data or even replay the data from a network calls. So it's really isolated, and it's really cheap and really fast. For the web, our test surface is much bigger. The same code that we write is used in all the browsers, in Outlook, in Office.com, everywhere. So our testing surface is much, much bigger. Therefore, we have to test against the live applications. And also because the type of data that we surface in the different applications is different, we need to use live data. Of course, we use test accounts, but that's just makes sense. You use test accounts as well. So we test in prod with live applications, test accounts, and we import the test, or we can also inject them. We do both. And then you need a test framework. For native, because the tests are really more platform specific, I will not go too much into details, but for the web, we need to define and run the test. Typically, this looks like that, where you have an ID that represents your application, and then a list of scenarios with a URL, a label for this scenario, some CSS selectors to show and hide elements. Then if you want to get some elements out of the way, if you have some widgets like a map or ads, banners, or so on. Then you have some selectors that would say how to interact with a page, click a button, enter some text in the title or in a search box and so on. And then you have some selectors that tells you on what to assert or what to screenshot, in this case, header and content. So it's really straightforward definition of a test, but there are some clear limitations with that. It's really designed more like a unit test. And one big drawback that we see is that for every test, there is a single interaction before taking the screenshot and closing the page and reopening the page again and moving on to the next test. Really, one test definition means open a page, do something, close a page, and then move on to the next test. For our use case, what we see is that the mid-guard applications are embedded in many websites, and these websites they can take a while, or they can take several seconds to boot up and to reach a state where you can actually interact or access a mid-guard application. And we cannot wait 5, 10, 20 seconds just for the application to boot up for every single test. So we created our mid-guard end-to-end test framework, which is designed to run end-to-end tests with multiple interactions and screenshots. The goal is really to open the page once and run all the tests you can, all the tests that you need, take all the screenshots that you need, and then close the page. That way you really make the best use of your sessions. So how it works is that the test framework opens the host application, say Outlook, Office.com, Bing, with the build that you want to test and the feature flags that you want to test. Then it imports the test code or inject it via the test runner. Test many end-to-end scenarios, really full scenarios, request many screenshots, take some performance or CSS measurements if you need, and eventually close the page. And then move on to the next application where you test again the same build, maybe with different feature flags and so on. And the test definition look a bit like this. So you just have the ID or the name of the test, in this case office.com, the URL where you want to open this application with some corresponding arguments about the feature flags that you want to enable for this test, which build you want to test, and then you can define the actual runtime test file and some dependencies. So much simpler. And then it is the responsibility of the test themselves to test and to handle the workload. The test code looks a bit like this. We just have a library Midgard test automation that typically waits for the Midgard application to be ready on the page. It might need to click somewhere on the page to activate something, say to open an email so that then you see the name of the person and then you can access or interact with this person control. And then we test the card for different personas and complete. The tests are really high level, but they test many scenarios and they go really, really deep. The limitation we see with this is that we still cannot test the host app integration, but that's because the host app integration is really depends from one host application to another, from Outlook, Office.com, Bing.com, you name it, SharePoint, OneDrive. The way that they handle different actions like open a mail, send an email, start chatting, opening a document is really different, and it's not always possible to test that. If they open a native application, you do not know if this operation succeeded from the JavaScript side. So the end-to-end testing pipeline looks like this. We can run it from command line and parts of it from CI. The tests ideally are part of a package, and that allows them that when you write a code change, the dependency graph will collect the test to run as part of a dependency graph of code that you did change in your PR, and then the test run against the tip of master. The screenshots become build artifacts, and then we can easily dip them and report in the pull request. And the result of that is that all our end-to-end tests across platforms, they really test the applications really deep. Right? They really test hundreds of thousands of scenarios, which is perfect. It's really what we want. And we also end up with many screenshots because we also want to make sure that across the different browsers, the style does not regress because we do not control the whole stack. Like a different application that consumes a mega application inject global JavaScript, global style sheets that interact with our components in ways that sometimes are breaking. So we really need to do these screenshots to see what happens in the live websites. And that brings us to the visual regression testing. So what we saw before about the end-to-end testing is that we have platform-specific ways to run the test that really covers many scenarios and produce screenshots. And so this part is platform-specific. Now, the end result is that we get many screenshots, and it doesn't matter how they are produced. We can diff them. We can compare the screenshots in a single manner so that we can really bring some values for all the platforms. The tool that we used initially to compare the screenshots is Pixel Match by Mapbox. It is very small, very simple, very fast JavaScript library to compare images pixel by pixel. And it has been made especially popular by a blog post about how American Express does visual regression testing with Jest and React. And the way it works is that Pixel Match looks at the pixel buffer of the image at the 8-bit integers buffer and compares the red, green, and blue values. So let's go. We have a very simple example here, and let's go through it. So it looks at first the alpha component of the baseline at the top and candidate at the bottom. And if they are the same, fine. Looks at the red component, same, fine. Look at the green, same, fine. Look at the blue, same, fine. And then, okay, that was the same. So let's output a washed out version of the pixel. And we do the alpha, the red, the green, the blue component. Now let's move on to the next pixel. We compare the alpha, it's the same. The red, that one's different. Green, different as well. The blue is different as well. Okay, so let's output the alpha of a highlight pixel with full alpha, full red, and no green, no blue. And we move on to the next pixel. Compare the alpha, the red, the green, the blue, output a washed out version of it, and so on and so on. So the nice thing is that then if we compare a baseline screenshot against what we had, suddenly we get this type of things. We get a washed out view of our component of our app with in red really an highlight of what changed. So it's a huge step forward. Here you really see what that something changed. The problem is that you cannot tell what actually changed in which way. If I see this, I cannot say if I would accept or reject a pull request. So this is not really actionable. Also, it's not so fast. You saw that there were many operations, and it's really difficult to read, and we completely lost context. You could display the baseline and candidate screenshots in pull request, but these screenshots might be stored behind authentication, and then it gets really complicated to show 3 screenshots from different storage to anyone in mail even. It gets really complicated. So we built a screenshot diff package, which is extremely fast, and the goal is to really to be extremely fast and give actionable screenshots. So it gives a lot of context, and you can think of it as a Git diff, but at the pixel level. Like when you're looking at the pull request, but imagine that for pixels. The way it works to be extremely fast is that instead of looking at the colors byte by byte, it looks at them as 32 bits integers. So first, we look at 1 pixel, 32 bits integer, the whole RGBA value for baseline candidate. And if it's the same, good, we output a washed out version right away, like the 32 bits. If we see that they are different, like at the next pixel, then we drill down to look at the individual components. And then we output right away, boom, a 32-bit integer that highlight the difference and so on, just looking at 32-bit integer. So we cut down the number of comparisons by 4, and there are more optimizations, and it also works across multiple cores. What we get now is, well, before we only had this thing in the middle, but just highlight that something changed. Now, if you look just at the right-hand side, you see your current change, and in red, you see a ghost of the pixels that basically were removed. And the same on the left-hand side, you see what was the state before, and in green, a ghost of what has been added. So if you just look at the middle, it's hard to say if you would accept or reject change. If you look at both sides, then it's really clear that we just changed the string and the change is acceptable. If we go back to the first example, where we only had the thing in the middle, it was impossible to say what to do with a change. But now, if we look at the change from my pull request, I see what this application looks like, and in red I have a ghost of what it was before. And it's really clear here that basically we only changed the typography and margins. And that was the intent of the change. So we can just accept it and move on with a merge pull request. So one thing is that the midguard applications are really third-party components. They really behave that way. They live inside different host applications, and we can still see these host applications in all the screenshots. Like if you open Outlook and then you click on someone, you would see a profile card of this person pop up. but Outlook is still behind with everything. So for us, that is noise, and we need to normalize that. So at the beginning of the test, our test library inject some CSS rules to normalize a bit the page. And one of the key things is that we hide everything from the body that is not our components. We avoid custom scroll bars. One thing which is actually pretty important to avoid the noise is to put the caret, the cursor that typically blinks in text box or input, to transparent, so you don't get noise of this blinking cursor. We also collapse in time the transitions and animations so that all transitions and animations are really instant and you don't get screenshot at a random point in time. Also, one really nifty thing is that web browsers know how to render images. Like they have rendered images for 25 years now. So we don't need to test that. So we just apply a filter with a brightness of 0 on all images. And that way we black out the images. We don't need to get noise for like half pixel precision or these kind of things. And that is something like this now. You see the card and images that are really images are blacked out. We still get the ghost in green and red on both sides. We also added, as we use this library, a low resolution highlight that really shows where are small differences in pixels that would be difficult to find. And we also optimized this library a lot, really, to the point that on commodity hardware, we can diff over 1,000 screenshots per minute, while that was completely out of reach for pixel match for our use case. So if you want really wicked fast side-by-side screenshot diffing, I recommend that you npm install screenshot diff. You can try it, tell me what doesn't work for you, and I will try to help you and make it suit your use case. In summary, how we test Midgard is through a set of static tests using TypeScript, ESLint, and Prettier at dev time to make sure that all the code you write is statically correct and strongly typed. We have unit tests that not only cover the happy path. We run many end-to-end tests and visual regression tests manually from command line and from CI against the tip of master to test our components. At the moment, mainly on web, but we also have some tests for platforms. We eventually, when we validate a bit, we do a bit of manual testing, mainly for the host app integration, which are really depending on which application consumes our components. And then when the code is out and released to production, which we do gradually, we keep monitoring and use real-time alerting to act immediately when there is any regression. With that, thank you very much for having me. You can find me online as Spizio1, and with your help, I would like to improve the state of visual regression testing for everyone. Thank you.